Hello friends. So today we will discuss about bitwise operators. So bitwise operators are special operators and used for bit level programming, and it performs operation directly to the bit level. So these are the bitwise operators, bitwise and bitwise or XOR, not operator, and left shift and right shift. So we can check with some examples. Here we are one variable int a is equal to 5. Int b is equal to 3. And we have one variable int c is equal to 0. So the binary representation of 5 is, we can just calculate like in 4-digit 0, 1, 0, 1. So this is binary representation of 5. So what is the binary representation of 3? That is 0, 0, 1, 1. Okay. So we can tell C is equal to A and B. Then we can just print the data, printf %d, comma, we can tell C. So here what will happen in C is equal to A and B means if both bit are 1, then we will get 1. Otherwise, it will be 0. So A and B means here 0, 0. Then it will come 0. Next is 1, 0. So it will come 0. Next is 0, 1. That also both are not 1, right? So it will come 0. And the last one is 1, 1. So it will come, both are 1. So it will come 1. So C equal to A and B means 0, 0, 0, 1. So this means in binary, in decimal, this is 1, right? So we will run this, we will get output 1. See, we are getting output 1. So A and B means if both bit are 1, then only we will get 1. Otherwise, 0. Okay. So next is the bitwise OR. Suppose we are telling like C is equal to A or B. A bitwise B. So that means if any bit is 1, then it is 1. Otherwise, 0. So here 0, 0 means 0. Next is 1, 0. That means this is 1. And next is 0, 1. That means this is 1. And next is 1, 1. So that is also 1. Okay. So this is 7. Right? 1, 2, 4, 6 plus 1, 7. So we will run this, we will get output 7. See, we are getting output 7. Next is bitwise XOR. A XOR B. So in this case, if it is a different bit, then it will come 1, otherwise 0. So here 0, 0. then 0 only. Both are same only, right? And 1 0, that means here it will come 1. And again 1 0, that is different bit, right? So it will come 1. And 1 1, same bit only. So it is come like 0. So here it will come 2 and 4, that is 6. So A XOR B means we will get 6. You can just run, we will get 6. Okay. Next is bitwise not. So we can just tell noted. Noted means this is the two's complement concept. But generally we can use like a formula, just like n plus 1 into minus 1. So suppose we are giving 5, then 5 plus 1 is 6, and into minus 1, that is minus 6. So we will get output like minus 6. See, we are getting minus 6. Here we are telling there is no B. Then we will get output 3 plus 1, 4, 4, minus 4. So minus 4. So we can use this formula, minus of n plus 1. Okay. Next is left shift operator. So in this case, we can tell A left shift 1. So A is equal to 0, 1, 0, right? So A left shift 1, that means this will move to here and adding 0 in the last position. Okay, so the now the value is, this is 2 raised to 0, 2 raised to 1, that is 2, 2 raised to 2, and 2 raised to 3. So 8 plus 2, that is 12. A left shift 1 means we will get 10. See, we are getting 10. Suppose here we are doing like A left shift 2, then we just added 0 here. So 2 raised to 0, 2 raised to 1, and 2 raised to 2, and 2 raised to 3, and 2 raised to 4. So 2 raised to 4 means 16, and 2 raised to 2 means it is 4. So we will get 20. Just run this, we are getting 20. Okay. Now we can check a right shift 1. So this is the A value 0, 1, 0, 1, right? That is 5. So A right shift 1. That means it will remove 1 from here and add 0 here. So that means 0, 2. So we will get 2 here. See, we are getting 2 here. A right shift 2. So what will happen? It will remove the right push, right bit. And we can add here 0. Then we will get 1. Okay. So these are the bitwise operators. Okay, thank you. Thanks for watching. Please subscribe.